Let's talk about the invisible force that powers our world, electric charge, and the fields it creates.
So you've probably seen this before, right? A comb picking up paper? Well, the answer is all about charge.
Here's our game plan. We'll start with the basics of what charge is and work our way up.
Okay, so what is charge? Basically, it's a fundamental property of matter, a bit like mass.
And here's a key rule. Charge always comes with mass. No mass, no charge. Simple as that. Charge is also a scalar. That just means it has a size or magnitude, but no specific direction.
Now, this is where it gets really cool. A charge's motion completely changes the fields it creates.
The rules are super simple. Like charges repel each other, and opposite charges, they attract.
So, an object's total charge is just a numbers game between its electrons and its protons.
This leads to a really important idea called quantization. Basically, charge comes in tiny, distinct packets. Yeah, charge is transferred in whole numbers of electrons. You just can't move half an electron. Okay, so charges attract and repel. But how do we measure the strength of that force? That's where Coulomb's law comes in. Part 1, the bigger the charge is, the stronger the force.
And part 2, the force drops off really fast as the charges get further apart.
Put those two ideas together and boom, you get the full formula for the electric force.
A charge doesn't just interact one-on-one. It creates this invisible field of influence all around itself.
And how strong is that field? We measure it by seeing how much push or pull it gives.
Now, what happens when two opposite charges get really close? They form a little team called a dipole.
And here's a common trip-up. The electric field and the dipole moment point in opposite directions.
Finding the dipole's total field is actually pretty straightforward. It's just a simple logical process.
Put that dipole in another electric field, and it'll feel a twisting force, a torque. So, when you get right down to it, everything from a spark to your phone starts with charge.
But that leaves us with one last question. If charge can't be split, what about quarks?